Hello, my name is Mohammed Ameen from Chemistry Department, and my presentation today is about modified silica-based monolith coupled with mass spectrometry for forensic investigation. In this work, the use of pristine C8 and C18 modified silica-based monolith were explored as substrate for laser desorption ionization mass spectrometry. The short form is LDI-MS, for sensitive and selective detection of analytes of different polarities. LDI techniques utilize different substrates of different physical and chemical properties, size, morphologies, and thermal conductivities to stimulate the ionization of analytes and enhance its detection sensitivity in the solution. One of the limitations of the LDI-MS is the selectivity towards particular analyte. So if you have a mixture of analyte in a solution, it will detect all the analytes with different degree of sensitivity, but it will not show any selectivity towards any particular analytes. That's why in this work, we have tuned the surface chemistry of the silica-based monolith to enhance its selectivity towards non-polar analytes. So we made the hydrophobic silica-based monolith, hydrophilic silica-based monolith, and moderately hydrophobic silica-based monolith. And we study its efficiency towards different analytes of different polarities. So the objective of this work are synthesis and characterization of silica-based monolith with different functional group, then the use of silica-based monolith for the detection of molecules of different polarity, and you will see, does it show some selectivity towards particular analyte here. In the last effort here, we will do like a real case scenario where the monolith will be used to detect drugs in beverage samples, just to mimic a forensic application scenario here. The methodology of this work is here. Synthesis of silica-based monolith was carried out using a sol-gel method. Then C8 and C18 functional group were introduced into the monolith. The monolith were sonicated in solution containing C8 and C18 for 3 hours at room temperature, and then washed with acetone, followed by drying at 40 Celsius for 24 hours. Characterization of the silica-based monolith were carried out using different advanced analytical technique. I will explain here two techniques, which is scanning electron microscopy and the FTIR. For SALD measurement, 5 mg of the monolith was suspended in 1 ml of TA90 solution. Then, using a micropipette, 3 layers of the substrate suspension were deposited in the 3 spots of the target plate. After drying, 3 layers of the analyte were deposited on the top of the substrate, while for the beverage experiment, 1 ml of the drug was spiked in the beverage, and then 1 microliter of the drug spiked beverage and the suspension of the monolith, in particular C18 silica-based monolith, were mixed and deposited in the plate. Let's look at the results here. First, let's start with the characterization. The first figure here shows the SEM micrographs. The SEM results showed that all the monoliths have similar morphology, comprised of well-defined and homogeneously distributed macropores. While if we look at the FTIR results, the FTIR bands at 1815, 957, and 1094, 1663, and 3454, which are really associated with the presence of Si oxygen, SiOH, and the bond oxygen were related to the Si and Si. So silicon, oxygen, silicon, and OH bonds. Other peaks also which is associated to the CH bond, symmetrical and antisymmetrical vibration were also observed. SALDI measurement. Initially, we studied the selectivity of the monolith towards 3 different analytes of different polarities. Vitamin C as a polar analyte, carbazole as a non-polar analyte, and caffeine as moderately polar analyte. The result clearly demonstrates that the intensity of vitamin C decreased when the hydrophobicity of the substrate was increased. On the other hand, the intensity of the carbazole peak decreased when the hydrophilic silica monolith was used, and it was increased when the C18 silica-based monolith, which is hydrophobic, employed as a substrate. Thus, the signal intensity was greatly influenced by the nature of the substrate. In the last effort, as can be seen here in this figure, we spiked a drug in beverage sample, then we mixed the drug spiked beverage sample with 1 microliter of the substrate, in particular the hydrophobic one, which is C18 silica-based monolith, and we run the SALDI-MS. In the SALDI spectrum, the SALDI peaks in the spectrum at 267.3 and 295.43 corresponded well with the protonated forms of disapramine and trimimapramine, with limit of detection in the range of 10 microgram per ml and 1 nanogram per ml. The lower limit of detection observed for trimimapramine can be related to its more hydrophobic nature compared to that of the disapramine when the silica-based monolith, which is hydrophobic C18 SiO2 substrate, was used. So, in conclusion, in this study, we prepared 3D, which is monolith, the monolith, silica-based monolith, C18-based monolith, and C8 and C18-based monolith as efficient SALDI substrate to detect small molecules of different polarities. The finding proved that C18 silica-based monolith can be applied to the analytes of drug-inspired carbonated beverage, and it can be used for any beverage samples as well. That's why this new SALDI platform should stimulate the development of other active substrate for the analytes of target analytes in forensic samples. Thank you very much.